Today I'll show you how to smoothly change your VRoid character's textures through the use of shader graph in Unity. We're going to make our own Crossfade Transition and modify the MToon shader used in the UniVRM plugin. This video is part 2 of my tutorial on swapping textures, so I highly recommend you to watch the previous one first. Just like the previous tutorial, I highly recommend you to download the project files from my GitHub page and open up the before tutorial folder in the Unity Hub. Here, I've upgraded our project from standard 3D pipeline to universal render pipeline, since shader graph can be used with the standard 3D pipeline. If you want to import your VRoid models in universal render pipeline, I've made a tutorial for it right here. Before we modify the shaders used by the UniVRM plugin, we must first understand what a shader is. You might have heard of shaders when you tweak the settings in some games, and you may know that shaders can make games look prettier. A shader is a small script with some mathematical equations to calculate every pixel drawn on the screen. When implemented correctly, you can do so many things with it. This wavy water, it uses a water shader. The wind movement on the grass, it's not animation, it's a shader. But not all shaders are that fancy. The simplest shader is just to control the color of an object. And we're going to make that right now. In Unity, right-click on the Assets folder, choose Create, Shader Graph, URP, Unlit Shader Graph. Let's name it Shader Change Color. Double-click it to open the shader graph window. We're going to need more space to work with, so let's first pop the shader graph window by dragging it out and click on the maximize icon on the top right. If you have multiple monitors, I highly recommend putting this shader graph window on another monitor. There is not much in the shader graph window right now. Here we only have a master stack, which is the final output for the shader. Every calculation we do in this window must eventually end up on this master stack. For now, let's just focus on the base color property. We want to change the color of an object, so let's create a color node by right-clicking on any empty space and choose Create Node. Let's type in color and press Enter. We now have a color node. Let's move this color node a bit and then click on the output of this color node and drag it to the base color property in the master stack. There you go. Now the node is connected. Now, if we change the color in this color node, you can see in the main preview window on the bottom right, the color of the shader also changes. So let's implement this shader in the game. Let's click on Save Asset on the top left of the window and go back to the main Unity window. Let's create a basic sphere to implement our shader and call it Test Sphere. But a shader can't be directly assigned to an object. We can only implement a shader to a material. So let's first create a material and name it Material Color. Click on it, and on the top side of the inspector window, click on this drop-down menu, go to Shader Graphs, and choose our shader change color. Then drag this material to the sphere. And voila! The sphere changes its color. But what if we want to change the color again? We could go to the shader graph window every time we want to change the color, but there is an easier way to do it. Just like in regular scripts, we can create variables that we can change from the inspector. So let's open the shader again. Right-click on the color node and choose Convert to Property. The color node has changed, and we can now see that color has been added to this window. So let's click Save Asset again and return to the main Unity window. Now, if we click on the material color in the inspector, we can see there is a new color property. And if we modify this color, the sphere changes its color too. Nice! But what if we want to create two spheres with different colors? If we duplicate this sphere with Ctrl-D and we modify its color, the other sphere also changes its color. Well, all we need to do is to just create another material using the same shader. So let's duplicate the material and drag the new material to the new sphere. Now, when we change the color of one material, the other sphere doesn't change its color. Remember, every material can only use one shader, but a shader can be used by multiple materials. In any case, congratulations on creating your first shader. With the basics covered, we can now move on to the goal of this video: crossfade transitions between two textures. Let's create a new unlit shader graph called Shader Transition Crossfade and open this new shader. First, let's create two new Texture 2D asset nodes. These will be the two textures we can switch to. I've prepared two example textures we can use in the Textures folder, Transition Example. Drag in the two textures to each of the Texture 2D asset nodes. To use this texture in the shader, we're going to need a node called Sample Texture 2D LOD. Let's make another one and connect the two Texture 2D asset nodes to each of the sample texture nodes. Now here's the fun part. To crossfade from one texture to another, we're going to use a lerp node. You might remember that we touched on lerp or linear interpolation back in the Genshin Impact Look at Nearby Object video. This node blends the two input textures together. The third input here is the transition value, or T value. You could think of this T value as a slider from 0 to 1. To demonstrate this, let's first connect the two sample texture nodes to the lerp node. And then, let's create a slider node and connect it to the T value. When the T value is 0, the output is exactly like texture 1. When T value is 1, the texture is exactly like texture 2. But when it's in the middle at 0.5, the output is the perfect mixture of texture 1 and 2. So, if we control this T value, we can create a crossfade transition between texture 1 and texture 2. Now, we want to connect the output lerp node to the base color property in the master stack. Finally, let's convert these Texture 2D asset nodes into properties. Right-click on their name in the left window and rename it to Texture 1 and Texture 2. Make sure that Texture 1 is the first input of the lerp node. Let's also convert the slider into a property and rename it to Transition. Click Save Assets and return to Unity main window. Just like before, let's create a new sphere and new material. Assign the material to our new shader and apply the material on our new sphere. Now, if we click on our new material and play with the slider, we can see that the texture changes from one texture to another. But actually, we're not quite done here. Let's drag in our normal character's One Piece texture and the Evil Tops texture to our material. If our texture has some transparent parts, the shader won't show the texture as transparent. It will instead show the transparent part as black texture. This is because we have no input on the alpha value on our shader. So let's go back to the shader graph. And on our Graph Inspector window, we want to open the graph settings. Scroll down and check the alpha clipping option. And while we're here, also change the render face to both so we can see our texture from front and back. Now, right now, we want to put in a value for the alpha property. We can do this by splitting the output from our lerp node using a new split node. In Unity, every color is defined by 4 numbers: red, green, blue, and alpha. Each of these numbers ranges from 0 to 1. For example, magenta is 1, 0, 1, 1. Orange is 1, 0.5, 0, 1. And black is 0, 0, 0, 1. The last number determines the transparency of that color, where 0 is invisible and 1 is fully opaque. The alpha property in the master stack only takes one value. We can just plug in the output of the lerp node directly, because then the alpha property will take the first value, which is the red value, as the alpha instead. That's why we need the split node to specify we want to plug in the alpha value of the color. Click on Save Asset and return to the Unity main window. Now we can see that our transparent texture now appears properly without any black texture. But there is still a problem. When we play with the transition slider in our material, there is an abrupt change where the texture suddenly becomes non-transparent. This is what the alpha clip threshold property used for in the shader graph. We're using an opaque shader, meaning that the transparency of a material can only be visible or invisible. It can be somewhere in between. Alpha clip threshold controls the limit. Any opacity below this value will be invisible, while any value above it will be visible. We can change our shader to be a transparent shader, but if we do so, we can always see objects behind our character, which is not what we want. The solution here is called dithering. This is a technique used in many games to make opaque shader look transparent. What it does is that as the alpha value drops, some pixels of the texture start to disappear in regular intervals, until at alpha 0, all of the pixels in the texture disappear completely. Adding this in the shader graph is surprisingly easy. First, we want to create a dither node. Type in 1 in the in property, and then create a screen position node and plug it into the screen position in the dither node. Finally, plug the output of the dither node to the alpha clip threshold. And that's it! Click on Save Asset, and now when we play with the slider, we can see that our texture transition is now smooth. Now it's time for us to implement the shader in the MToon shader. Open Shader Transition Crossfade again, and select every node except for the master stack. In your keyboard, tap in Ctrl+C to copy it. Back in Unity, in the project window, open Plugins, Shader Graph MToon, Shaders. Let's duplicate this MToon shader with Ctrl+D and rename it to MToon Transition. This is so that we can always have a default copy when we need them. Double-click to open it in the shader graph. First, type in Ctrl+V on our keyboard to paste in our nodes. Let's start from the easiest first. Convert our slider node into property and name it Transition. For our convenience, let's move this property upward to below the Shade Texture property. Next, select and drag our Screen Position and Dither nodes to the bottom near the master stack. Just like before, we want to connect the output of Dither node to Alpha Clip Threshold, replacing the cutoff node. Then we can just delete this cutoff node and its property in the window on the left. Next, we need to pull this main text node and sample texture to the LOD upward. Connect the output of the lerp node to this lower multiply node. Then connect the alpha output of the split node to the upper multiply node. They are both multiply nodes, so please make sure that you connect the right one. If you make any mistake, don't be afraid to use Ctrl-Z to undo it. We can now delete this main text and sample texture 2D nodes from this shader graph. Now let's convert our 2D texture nodes into properties. Rename them main text 1 and main text 2. Let's move these new properties above the original main text property and then delete the original main text property. Now, only one more thing left to replace, which is the shade texture. We want to duplicate our copied transition nodes again, but this time without the split node. Drag this shade texture and sample texture to the LOD up. Connect the output of the lerp node into this multiply node. Now, we can delete this sample texture to the LOD node and drag the shade texture node to near the sample texture node that we've just copied. In the left window, right-click on the shade texture property and duplicate it. Rename both of them to shade texture 1 and shade texture 2. Finally, replace the main text 1 and main text 2 with shade texture 1 and shade texture 2. And that's it! Click on Save Assets and return to the Unity main window. To use this new shader on our Vita model, let's open our Vita Materials folder, select Shoes, Tops, and Body Materials, and change their shader to our new MToon transition. Then open each material and drag in the new evil textures to the main text 2 and shade texture 2 field in the inspector. When we enter play mode, if we select all three materials, we can now play with the transition slider to change the clothes back and forth. If we want to make it automatic, we can just animate the slider property by adding it into the animation. Open up the animation window, click on the drop-down menu, and choose Facial Transition Normal to Evil. Let's add new property by clicking the Add Property button, choose Body, Skin Mesh Renderer, Material Transition. Click on the plus icon next to it. Let's add two new animation keys for the transition property when the background changes to red. Fill the first one with 0 and the second one with 1. Now we do it again for facial transition evil to normal, facial evil, and facial normal animations. When we go to the play mode, we can see that it's working perfectly. There is even a way to transition between three textures if you want to. Expanding on our script from the previous video, all we need to do is to swap the second texture with the third textures when it's not shown. First, we need to duplicate the swap texture script. After all, we still need the original component to swap the eye color. Let's call this new script Swap Texture Shader and open it. Let's rename the class name to Swap Texture Shader. Otherwise, the script won't run in Unity. In this new script, we just need to change the strings from main text to main text 2 and from shade texture to shade texture 2. Save the script and return to Unity. Now let's put this new script above the original component and drag in the evil textures and the new Fifi texture in the texture folder. Lastly, let's open the swap controller script, and we're going to add a reference to swap texture shader script and a new button. right below the previous button. Don't forget to add the reference to the component in the inspector. And when we go into play mode, if we press switch pose, it will first change to the regular evil texture. Click on swap second texture and switch pose, and it works. Note that the animation and the eye color don't change their color because we haven't made the animation for them yet. This demonstration is just to show that it is technically possible to switch between multiple textures even with the shader. And there we go! This tutorial is just to scratch the surface of what is possible with shader graph. If you felt lost anywhere in this tutorial, feel free to download my project files in my GitHub page. Let me know in the comment section below if you guys want some shader tutorials in the future. If this video helps you, click on the like button. I make a tutorial like this every once in a while, so if you want to see more, consider subscribing and ring the bell. And with that, I think I'll see you guys later. Goodbye!